I am Dr. P. Ramadevi from Institute of Aeronautical Engineering. Today in the computer networks, we are discussing about the switching techniques which comes under the module, the physical layer. So introduction to physical layer, let us as a part of the introduction to physical layer, we are going to discuss about the switching techniques. So what are all the different types of switching techniques, and then the why to go for switching techniques, all about all these things we are going to discuss in this particular lecture. um, Previous class we have discussed about the transmission media, different types of transmission media. So as a continuation of that one, today we are going to discuss about the switching techniques in the physical layer of the computer networks. Let us start. So here the purpose of the switching networks is, in large networks there can be multiple paths from sender to receiver. So the switching technique will decide the best route for the data transmission. So this particular technique is used to switch from as there are multiple paths from sender to the receiver. Which path is the best route? For deciding those things, we go for the we go for the switching techniques, and this is for the best route in the data transmission. So this switching technique, this is used to connect the systems for making one-to-one communication. So the switching means from connecting the many paths, multiple paths, and then deciding the best route for data transmission. And this technique is used to connect the different systems for making one-to-one communication. Classification of switching techniques. There are different classification of switching techniques. So here, as we see here, the switching techniques are of three types. One is the circuit switching, another one is the message switching, and then the third one is the packet switching. So the circuit switching is classified as the space division switches. Then circuit switching is circuit switching are of two categories. One is the space division switches. Another one is the time division switches. Then the packet switching techniques, we have several types of classification. So that is the datagram approach. Another one is a virtual circuit approach. In the virtual circuit approach, we have two things, two classifications are there. One is a switched virtual circuit (SVC), permanent virtual circuit (PVC). So let us discuss all these things elaborately now. So first of all, let us discuss the circuit switching. What is circuit switching? Circuit switching is a switching technique. It establishes a dedicated path between sender and the receiver. In this circuit switching technique, once the connection is established, then this dedicated path will remain to exist until the connection is terminated. Circuit switching is a network operates in a similar way as the telephone networks. A complete end-to-end path must exist before the communication takes place. So this circuit switching is it operates like a telephone networks. So continuation of that one. In case of circuit switching technique, when any user wants to send the data, voice or video, the request signal is sent to the receiver. Then the receiver sends back the acknowledgement to ensure the availability of the dedicated path. After this receiving the acknowledgement, dedicated path transfers the data. Here the process here is in this circuit circuit switching technique. When the user wants to sender wants to send the data, so a request is sent. This is a request. Request is sent to the receiver, and the receiver when the receiver receives this request, then it sends back the acknowledgement. So this shows that this shows that when the receiver sends an acknowledgement, this shows that there occurs a the receiver is the receiver when it sends the acknowledgements means one dedicated path is there for sending and receiving the data. So hence the receiver is ready to accept the data. So hence after receiving the acknowledgement, the the sender or the dedicated path will send the data. Data is sent after receiving the acknowledgement. So circuit switching, it is used for used in public telephone network, landline, public telephone PTN we call public telephone network. So circuit switching is used for that. So telephone networking, public telephone networking, circuit switching is used, and this is used for voice transmission. So by using this technique, the fixed data can be transferred at a time in circuit switching technology. So the communication through circuit switching, it has three phases. One is the circuit establishment, and circuit establishment. Another one is the data transfer. Third one is the circuit disconnect. So these are the three phases. So let us understand these three phases with the help of this diagram. So A is the sender, and B is the receiver, and the nodes here are here this is a sender and this is sending end node, sender receiver end node. Then in between these nodes are called the s1 to s1 to s6 is called they are called the intermediate nodes. So via these nodes the messages are sent, intermediate nodes. If so here, so first of all, the circuit, the first of all, the communication is established by circuit establishment. So all step by step process is done here. All these are programmed. So here in the circuit switching process, first circuit establishment will takes place. Later on, the data transfer will takes place. Then after transferring the data, the circuit the disconnect of the contact will takes place. So here the circuit this one circuit switching techniques are of two types we have discussed. So here circuit switching we have classification of circuit switching is space division switches. Another one is the time division switches. So let us discuss about the space division switches and the time division switches as a part of the circuit switching topic. Space division switches. Here the space division switching, it is a circuit switch technology in which single transmission path is accomplished in a switch. So by using this single path accomplishment in a switch, it is by using a physical separate set of cross points will be there. This space division switching, it can be achieved by using a crossbar switch. By using crossbar switch, this space division is accomplished. A crossbar switch is a metallic crosspoint. It is a metallic crosspoint or semiconductor gate that can be enabled or disabled by a control unit. A control unit is there which will make the crossbar switch. This is made up of metallic, and then this will make this control unit makes enable or disable the semiconductor gate or the metallic crosspoint. This crossbar switch is made by using the semiconductor. And the example for this crossbar switch is the Xilinx crossbar switch using FPGAs. Then another space division switching, they have the features of this one is it has the high speed, high capacity, and non-blocking switches are there. Space division switches, they are all of two types. One is the crossbar switch, another one is a multi-stages, stage switches. Many stages of these switches will also be there depending on the requirement. The space division switches are chosen. Crossbar switch. The crossbar switch, it is a switch that has n input lines will be there and n output lines will be there. The crossbar switch has n square intersection points. How many n square intersection points? They are known as cross points. Hence the name crossbar switch. So this has n square intersection points will be there. If the crossbar switch has n input lines, means n input lines are there, means it has n output lines. So are there. This will have n square intersection of these things. It will form n square. N square is the intersection points. They are known as cross points. So disadvantage of this crossbar is this increases as the crossbar points increases as the number of stations is increased. So as this is related, if n number of lines are there, means n square intersection points will be there. So because of that, this one, so the number of stations are also to be increased. So hence, therefore, this becomes very expensive for large switches. If we want to go for large switch, this becomes a large. Then it becomes an expensive thing. So solution for this crossbar switch is going for the multi-stage switch. So to reduce the different number of stations to increase. As the number of stations are increasing because of the number of cross points, so hence we go for the multi-stage switching. Because it is the using the same crossbar switch, the cost is more. So multi-stage. So solution for the crossbar switch is the multi-stage switch. Here in the multi-stage switch, multi-stage switch, it is made by splitting the crossbar switch into smaller units. So here, this switch itself is splitted into the crossbar switch into the smaller units. So here they are divided into smaller units, and then interconnecting them. After that one, it has to be interconnected. So because of this one, it reduces the number of cross points. So if one path fails, means then there will be an availability of another path. So that is the multi-stage switch. If one path fails, means there is a availability of another path to transfer. So hence here the splitting of the crossbar switch will take place into smaller units and then interconnecting them. So hence there are several advantages of the circuit switching. So in this circuit switching technique, communication channel is dedicated. So one particular channel is dedicated for switching technique. So it has a fixed bandwidth. Bandwidth is also fixed. There are several disadvantages of circuit switching. Once a dedicated path is established, the only delay occurs in the speed of data transmission. It takes long time to establish a connection, approximately 10 seconds, during when no data can be transmitted. It is more expensive than other switching techniques because it has a dedicated path which is required for each connection. This is also insufficient to use because once the path is established and no data is transferred, then the capacity of the path is wasted. So in this case, the connection is dedicated, therefore no other data can be transferred even if the channel is free. So hence, as there is a dedicated path, because of the dedicated path, there are some advantages and there are many disadvantages because of that one. Okay. So next one in the switching techniques, the second classification, first classification is the circuit switching. Second one is the message switching. Third one is the packet switching. So next one after circuit switching, let us discuss about the message switching. So message switching is a switching technique in which message is transferred as a complete unit. And message is a message, or only the message is transferred as a complete unit, and it is routed. And routed means it is sent through intermediate nodes at which it is stored and forwarded. So here store and forward technique is used whenever the message is sent. It is sent as a complete unit, and it is also sent through the intermediate nodes, whatever the nodes in between the sender and the receiver. Those nodes we call it as intermediate nodes. Through that nodes at which it is stored. So in the intermediate nodes, first of all the message is stored. Then afterwards, after storage, it is forwarded to the other node present in the intermediate nodes. In message switching technique, there is no establishment of a dedicated path between sender and the receiver. So here there is no establishment of the dedicated path between the sender and the receiver like circuit switching. So this has a there is no node establishment of the dedicated path. In circuit switching, dedicated path. The destination address is appended to a message, and there will be their destination address also will be there. Receiver's address is also mentioned in this particular message. So this message switching, it provides a dynamic routing because it provides a dynamic. What is dynamic routing? As the message is routed through the intermediate nodes based on the information available in the message. So whatever the information is there in the message, according to the information provided there, as the destination address is there in the message, so the message will reach through the intermediate nodes, and in the intermediate nodes, depending on the intermediate nodes are chosen. If suppose there are n number of intermediate nodes, means in the message, if it is mentioned only, suppose the node n2, the information has to be reached. So hence it goes through the intermediate node n2 only. So like that, over the message is routed through the intermediate nodes based on the information available in the message. Depending on the information available, the message is sent. So let us understand the message switching technique with the help of a pictorial representation. So the figure shows here the A, B, A is the sender and B is the receiver, and in between S1 to S6 are the intermediate nodes. These are the intermediate nodes. So how the message switching technique takes place? These message switches are all programmed. All these switches are S1, S2, S3, S4. We call these things as intermediate nodes as the switches. So here the message switches, they are all programmed, and they are programmed in such a way that they can provide the most efficient routes. Each and every node stores the entire message and then forward it to the next node. So this type of network is also known as stored and forward network. So stored and forward network it is called. Message switching treats each message as an independent entity. So each message, message 1, message 2, all these things, it will treat each message as the independent entity. So advantages of message switching. Data channels are shared among the communication devices that improve the efficiency of using the available bandwidth. Tran- uh, Traffic congestion can also be reduced. Congestion can also be reduced because the message is temporarily stored in the nodes. Message priority can be used to manage the network. The size of the message which is sent over the network can be varied. So this is that's why it is known as this message switching technique is a dynamic network. Therefore, it supports the data of unlimited size. As this is dynamic in nature, message switching will support the usage of data unlimited size. So, disadvantages, there are some disadvantages of message switching. The switches must be equipped with sufficient storage because each and every switch maintains the storage devices. Hence, it should have the sufficient space to store the messages, which enables them to store the messages until the message is forwarded. So, as it follows the message storage and the forward technique. So because of that one, first it has to store the message and it has to retain that message until the forwarding technique starts. The long delay can occur due to the storing, and because of the storing, what happens? Delay will increase. and forwarding facility provided by the message switching technique. So what is the disadvantages because of this message switching technique, as it follows the storing and forwarding technique, so hence the long delay will occur. Next one is the third one is the till now we have discussed about the switching techniques. First one is the switching. Second one is the message switching. Third one is the packet switching. So this packet switching, what is this packet switching? It is a switching technique in which message is sent in one go, and but it is divided into smaller pieces, and they are sent individually. The message splits into smaller pieces known as packets, and packets are given a unique number. So here, first of all, in the packet switching technique, the message is sent in one go, but it is divided into first smaller pieces, and but they are sent individually. These are the main things. Then after that one, in that message, each packet contains a unique number. So this is used to identify their order at the receiving end. This each packet contains some information in the headers, and some headers such as source address. So it will have these headers will have the source address, destination address, and a sequence number also. So we suppose the first second is sent, the next third is sent, but at the receive then afterwards one is sent at the receiver. So at the receiver, what happens is 231 like that, it is sent randomly. So when this is sent, these packets are sent, then at the receiver, when the sender is sending this one, so at the receiver all these packets are sequenced. So because it is identify the sequence number, so first one will come, next two, then three. So like that these packets are arranged. So packets will transfer across the network, taking the shortest path as they possible. So all these will have from sender to the receiver, or this will travel through a network. Network will have the intermediate nodes also. So this across the network, whichever is the shortest path, that is uh, one, two, one, two, three are there. Three nodes, one node, second node, third node, or else switch one, switch two, switch three are there. Suppose we have a path, the suppose if we want to send the message from S1 to S3, S1 to S3, we have a path like this, and we have another path from S1 to S2, S2 to S3. So suppose this has 2, 3 are the values for this one. So this takes how much 5 is the value it takes to reach to the S3. As you see here, from S2 to S1 to S2, let us give the value as 2. So compared to 5, 2 is less. So value of the path S1 to S3 is less. So hence this becomes S1 to S3. S3 is the shortest path compared to S1 to S2, S2 to S3. So the packets will travel across the network taking the shortest path as possible. So here the as you see here pictorially, all the packets are reassembled at the receiving end in the correct order. If any packet is missing or corrupted, what happens is then the message will be sent to the resend. Then will be sent to resend the message. Again, the message will be sent to again, and it will ask to resend the message. If the correct order of the packets is reached, suppose if correct order is reached means, then what the receiver, then the acknowledgement message will be sent by the receiver. As you see here, A is the sender, B is the receiver here, sending and receiving end. So here, let us say these packets are sent 4, 3, 2, 1 are the packets sent via the intermediate nodes or the via the switches S1, S2, S4, S6, S5, S3, all these things are the intermediate nodes. So these packets are sent, and from S1 to S2, packet number 4 and 1 is sent. From S2, 1 is sent, to S2 to S4. From S4 to S6, 1 is sent, and it is received at the receiving end as 1. Then later on, 3 and 2 will travel from S1 to S3. Then 4 from S2 to S3. Here the from 2 is traveled from S3 to S2, S3 to S4 because of the information available in that particular packet. Then afterwards it is sent through the S4 to S2. So 2 is sent, and then from S3 to S5, 4 3 is sent. From S5 to S6, as you see, 2, 4, 3 are sent combinedly, and at the receiver section, we receive the packets 2, 4, 3, 1. And after receiving this one, at the receiving end, these packets are, according to the sequence number given, they are arranged. So different approaches of packet switching, we have different types of packet switching, different approaches are there. One is data packet switching approach, another one is the virtual circuit switching. So two types of switching techniques are there for the packet switching. So first of all, let us discuss the first approach, datagram packet switching. So here, this is a packet data switching. This is a technology, datagram packet switching technology, in which the packets are known as datagrams, and they are considered as the independent entity. Each packet contains the information about the destination, and it switches using this information to forward the packet to the correct destination. So these packets are reassembled at the receiving end in the correct order. So this is the datagram packet switching. In the datagram packet switching, path is not fixed. So intermediate nodes take the routing decisions to forward the packets. So they take the routing decisions, intermediate nodes. Datagram packet switching is also known as connectionless switching. Next one is the virtual circuit switching. In the virtual switching technique, this is known as the connection oriented switching. The datagram technique is the connectionless services, connectionless switching technique, and virtual circuit switching is the connection oriented switching. So here in this case, virtual circuit switching, a pre-planned route is established before the messages are sent. There will be a call request and call accept packets, which are used to establish the connection between sender and the receiver. So in this case, path is fixed for the duration of a logical connection. So until the logical connection is there, there will be a path which is a fixed path duration for a particular fixed duration. So let us understand this virtual circuit by using the virtual circuit switching by using with the help of a diagram. Here the sender is there, A is the sender, B is the receiver, and 1 and 2, let us assume they are the nodes present, intermediate nodes. Then first of all, if a sender wants to send the data, it sends the call request. When the call request is sent, the receiver receives the call. Suppose if it wants to accept the call, then it will send the. Then what happens is then when the call request is sent, means the receiver accepts it. When a call is accepted by the receiver, hence the receiver then what happens is that receiver is ready to transfer. The receiver is ready to accept the data. Receiver is ready to accept the data. So hence the sender will sender will is ready to transfer the data. So when it wants to transfer the data, so acknowledgement is sent by the receiver. So now afterwards, when the acknowledgement is sent that the data transfer has happened, the sender will send the data, then transfer will take place, then the receiver will send the acknowledgement. Then the path is cleared. So this is after every after every connection, the every switching after the data transfer, the path has to be cleared always. So disconnection of the circuit takes place. So here this concept is explained here. In the A and B are the senders, and they are 1 and 2 are the nodes. Call request and call accept packets are used to establish a connection between the sender and the receiver. When the route is established, data will be transferred. After transmission of data, what happens? The sender, an acknowledgement signal is sent by the receiver. Receiver will the receiver will send the acknowledgement that it has it has received the data, so that the message has been received. If the user wants to terminate the connection, so if suppose there is nothing to transmit, means the user will terminate the connection. So because a clear signal is sent to the termination for the termination. So clear signal is sent for termination or the terminating the process. So difference between we can classify based on the techniques used. We can classify datagram approach and virtual circuit and their differences. Node takes in the datagram. Node takes route decisions to forward the packets. Virtual circuit approach. Nodes does not take any routing decision. Congestion cannot occur as all the packets travel in different directions. Here in the virtual circuit approach, congestion can occur when the node is busy and it does not allow other packets to pass through. In the datagram approach, it is very more flexible as all the packets are treated as an independent entity. But here, whereas in the virtual circuit, it is not very flexible. So advantages are of packet switching is they are cost effective. Therefore, that means in this techniques, switching devices do not require massive secondary storage to store the packets. So cost is minimized to some extent. Therefore, they are cost effective. They are also reliable. Packet switching is also reliable compared to the circuit switching. If any node is busy, means then the packets can be rerouted. This ensures that packet switching technique provides reliable communication. Efficient packet switching is an efficient technique. It does not require any establishment path prior to the transmission, and many users can use the same communication channel simultaneously. Hence, makes use of available bandwidth very efficiently. So there are some disadvantages of packet switching technique. This technique cannot be implemented in those applications which requires the low delay, high quality services, and then the protocols used in the packet switching technique, they are very complex and they require high implementation cost also. If this network is overloaded or corrupted, means it requires retransmission of lost packets. So this also lead to the loss of critical information if the errors are not recovered. So with this, studied about the different switching techniques. The first one is the circuit switching, second one is the message switching, and then the packet switching, their advantages and disadvantages. With this, we come to the end of the switching techniques. Hope you understand. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.